Welcome to this explainer. Today, we're unpacking a really crucial evolution in how we validate our code. Specifically, we're diving into Chapter 9, Observability-Driven Development. We're going to look closely at exactly why the old ways of ensuring our code works, well, they just aren't enough anymore when it comes to the wild, totally unpredictable environment of modern production.
So, let's dive into this incredibly frustrating reality that pretty much every single software engineer faces when deploying modern distributed systems. I mean, you've absolutely been there, right? You write the code, run your test suites locally, and boom, everything flashes green. You feel great. You merge the code with total confidence. But then, 2 a.m. rolls around and chaos strikes. Pager alarms are going off, customers are complaining, and production is literally broken. So what gives? Why on earth do our perfectly green passing tests completely fail to protect us from these late-night production outages?
To answer that, we're going to walk through this roadmap. We'll hit the limits of TDD, dive into production reality, compare the microscope to the telescope, talk about instrumenting the dev cycle, conquering deployment fear, and finally, wrap up with AI and the future.
All right, Section 1, the limits of TDD, specifications versus reality. We're starting with test-driven development, which has been our absolute gold standard for 2 decades now. But as we'll see, it's just no longer enough on its own.
The core difference here is actually pretty stark. TDD ensures correctness against a controlled specification, whereas ODD verifies your code's behavior against the absolute chaotic reality of production. Think about TDD for a second. It's an amazingly successful practice. You define behavior through tests, run them constantly, and use those failures to guide your implementation. But here's the catch. It only works because the environment is completely controlled. In TDD, your data resets every single time. Dependencies are neatly mocked out. All the while variability of the real world is intentionally stripped away. You're basically operating in a sterile, perfectly clean laboratory. But you know what? Production is definitely not a laboratory. Production is messy. It's packed with infinite variables, noisy neighbors in the cloud chewing up your CPU, sudden random network latency spikes, and, let's be honest, real human traffic doing bizarre, unpredictable things you couldn't possibly dream up in a test suite. So while the consistency of TDD makes your code logically sound, it simply doesn't expose you to the reality of the wild. And that right there is exactly where Observability-Driven Development, or OODD, steps in.
Moving on to Section 2. Welcome to Production Reality, the microservices shift. So what actually changed to make production so chaotic that our traditional debugging just falls apart?
Well, way before observability became the standard buzzword we all use for introspecting production software, early engineers grappling with this massive architectural shift tried to describe what they needed as strace for microservices. Now, if you remember, strace is a traditional system call tracer. It's an awesome diagnostic tool for sure, but it is strictly for a single machine. These engineers recognized that the old tools just weren't cutting it anymore. In the past, software systems had way fewer components. They were so much easier to reason about, and an engineer could basically just think their way through a problem on one server.
But today, you simply cannot use a traditional IDE debugger because it literally can't trace a path across a massive distributed microservices architecture. When we ripped apart our monoliths into dozens or even hundreds of microservices, the traditional debugger basically went blind. It can't hop the network. Think about a simple user checkout failing. In an old monolith, your debugger catches it right on line 42 of your cart module. Easy peasy. But in a microservice architecture, man, that failure might be caused by a timeout 5 network hops away, buried deep in some inventory service that's querying a struggling database. Because distributed systems communicate across networks, your code logic and the operational context of the system are irrevocably intertwined. A single change in performance can manifest in a dozen different ways across multiple services. If you have low observability, all you see is that your performance graphs are either spiking or dipping at the exact same time, and you have absolutely zero idea why.
Which brings us to Section 3, Microscope versus the Telescope, a new paradigm. This is a vital shift that completely redefines how we actually find our bugs.
Let's formally define OOD. It is the practice of bundling your instrumentation right alongside your new feature development. This is a huge shift in mindset. You don't just build a feature, chuck it over the wall into production, and then weeks later try to figure out how to monitor it. No way. When observability drives your development, you ship the new features together with the exact instrumentation needed to measure their impact. Practically speaking, this goes way beyond just relying on auto-instrumentation. This means developers are getting in there, actively creating custom spans, adding high cardinality attributes to their traces as they write the logic, and capturing the specific context they need to verify performance. You compare the new version to the previous one, and you debug it instantly the second reality disagrees with your assumptions.
I absolutely love this analogy from the source material. It says observability is the telescope that helps you aim the microscope. You still use your debugger microscope for the nitty-gritty logic, sure, but you absolutely need the observability telescope to find out where in the universe you're supposed to point it. TDD is fantastic for debugging your code logic back in the lab, but when you're out there in production, observability is for figuring out where in your incredibly complex system you actually need to look. High observability tools narrow down this massive, intimidating search space. They aren't replacing debugging, they're enabling it. They tell you exactly which component threw the error, where the latency is hiding, which network hop is hogging the processing time, and whether this wait time is hitting all your users or just a tiny specific subset. The telescope shows you exactly where the issue originates, so you can finally bring out your microscope and fix it.
Section 4. Instrumenting the development cycle. Shifting observability left. To actually use that telescope effectively, we have to shift our observability left, right into the development cycle.
Let's look at how this builds the case for speed. Because the longer you wait to detect a bug after deployment, the faster your memory decays and the more expensive the fix becomes. Just think about the psychology of a developer for a second. Right when a feature first ships, your intent is completely fresh in your mind, right? If a bug is caught within minutes, you can squash it instantly. But in a lot of organizations, developers merge their code, cross their fingers, and just kind of wait around to get paged. Sometimes the page comes in a few hours, but often, problems aren't detected for days, weeks, or even months. Think about how agonizing it is to context switch back to code you wrote 3 weeks ago. By that time, the context is completely gone. It becomes incredibly difficult to decipher what your original intent even was. The investigation becomes orders of magnitude more expensive, and suddenly, your team is forced to rely on blind rollbacks and pure stressful guesswork. To systematically eliminate that guesswork and actually return to science, your instrumentation has to capture rich operational context the exact moment you ship. The entire promise of high observability tooling depends completely on the quality of your instrumentation. You need to know exactly which half a dozen or more things must all be true for a specific error to happen. If your instrumentation is capturing this level of detail, things like your build IDs, instance types, and container versions, all within the context of your requests, well, you can start at the absolute edge of any problem and work your way to the exact correct answer every single time. There's no magic to it, no relying on gut intuition, just science.
So the crucial point here is establishing this incredibly rapid deployment loop where your intent meets reality immediately. And this isn't just some theoretical framework. This literally changes your daily sprint. First, you bundle the instrumentation right into your dev workflow. Next, you deploy often and successfully by decoupling deployments from releases using feature flags. This is huge because it puts you in complete control of the blast radius. Then, you observe the behavior of your new feature as it's slowly rolled out to real production traffic. And finally, you systematically isolate and fix any anomalies while the code is still completely fresh in your mind.
All right, Section 5, Conquering Deployment Fear, Building the Glass Castle. Once you establish that rapid loop, you completely transform the emotional experience of deploying code.
There is a stark contrast here. We are moving from terrifying black boxes that paralyze teams with fear to transparent glass castles where you can instantly see and react to what's broken. When you lack visibility, production is a fragile system of fear. Think about the last time you had to deploy on a Friday afternoon. An issue pops up, teams inadvertently take their foot off the gas, they painfully halt all deployments, and they blindly roll back changes without actually understanding what went wrong. It's just an anxiety-inducing cycle of slow, paralyzed action. But observability-driven development, it turns that scary environment into a glass castle. It becomes an interactive, fast-paced playground. Because engineers can see absolutely everything perfectly, they can confidently walk in, spot the exact issue, and roll back instinctively and comfortably at light speed at the slightest sign of trouble, fully understanding the root cause.
Building this glass castle directly improves your North Star metric, dramatically reducing the time it takes for your hard work to actually reach your users. Lead time to production is the ultimate measure of your team's velocity and confidence. And trust me, this matters deeply for the business side of things. Lead time isn't just an engineering metric. It's quite literally how fast your company can deliver value to customers without breaking the whole system. Observability-driven development supports this metric by removing all that paralyzing uncertainty during a rollout, making investigations lightning fast when reality inevitably throws a curveball at your code.
And finally, Section 6, AI and the Future, Scaling with Automation. Let's look at how ODD integrates with the rapidly approaching future of AI-assisted coding. By giving AI agents access to your telemetry schemas, They can actually check their own work against a known good pattern before they even deploy. We've talked about blending test and observability-driven patterns, and AI makes this combination incredibly powerful. Tools like OpenTelemetry Weaver allow you to build and enforce strict data contracts for your telemetry attributes. If you shift this all the way left, you can give your AI agents direct access to these schemas. The AI can then run local validation against the telemetry emitted from a service. Think about that. The more the AI can automatically verify its own changes against these explicit standards, the faster and, much more importantly, the safer it can make changes to your codebase.
I want to leave you with this somewhat provocative thought. As the development lifecycle rapidly collapses under AI speeds, is your team ready to rely on observability as your ultimate validation tool? When AI agents begin shipping code much faster than a human could ever manually review, our traditional quality gates are inevitably going to fall away. Instrumentation and observability are no longer just a nice-to-have practice for debugging. They literally become the primary mechanism that validates your entire development lifecycle. That telescope we talked about, it is your final safety net. Thank you so much for joining me on this explainer. Ensure your instruments are sharp out there, and happy observing.